Yes, in the previous class, electrogravimetry, that part is completed in a previous class. And at the end, how to determine the copper by electrogravimetry technique, that part is completed. Now we go for the one more technique, that is flame photometry. This is also one of the analytical technique. And here, this technique is based on the measurement of the intensity of the light when a metal is introduced to the flame. Already in fourth semester, you have done the flame test. And in the flame test, some of the metal ions, when they are subjected to the flame, they impart a specific color. For example, sodium, it impart golden yellow color. Potassium impart lily color. Similarly, calcium impart brick red color. Barium imparts the apple green color. Like that, when these metals are introduced to the flame, they impart a specific color. And in this technique, when a metal is introduced to the flame, color is imparted, and the color of the intensity determines the amount of the element present and also wavelength. The most important is what is the wavelength, and depending upon the wavelength, it imparts the specific color. And here it is one of the spectral technique in which the atomic excitation takes place. Means whatever the element is there, say you can take sodium element, when it is placed to the flame, what happens there? The sodium, which is in a metallic form, and that metal is on thermal heat, what happens? It is split up into atoms and their atomic excitation takes place. That is, when a metallic solution is sprayed, what happens here? To the metallic sample, to the flame can serve as a atomic emissions. The flame can act as an atomic emission, and we get the different spectral lines, and also absorbing medium you have to know. And this flame photometric technique is further coupled with the simple readout device, produce a high sensitivity, high reliability for the determination of several elements, and here the sodium and potassium radicals are determined from the fluids as well as the from tissues. We know different types of fluids. You can take body fluids are also there, tissues are there, and from those fluids we can determine the sodium percentage, potassium percentage, or any element that is required, and that can be determined here. Then what is the principle behind the flame photometric technique? Here the principle is, when a sample, means a metallic solution, we can say the metallic salts are dissolved in a solvent and make a solution, and when that solution of the metallic component is subjected for the sprayed, means a spray can be done, and this metallic solution is sprayed to the flame, what happens? There are some following phenomena are rapidly occurs. The first one, you can take the metallic component or metallic salt, and this is dissolved in a solvent, and we get a solution, and this solution is, when it is allowed to comes in contact with a flame in the form of a spray, what happens? The first evaporation is going to be taking place. Here, whatever the solvent is there, this solvent is get evaporated, because when it is applied to the flame, what happens? Immediately the solvent is get evaporated and leaving behind a solid residue. Leaving behind a metallic solid residue is left behind, and this is called as evaporation. The second one is vaporization. What is going to be vaporization? Means whatever the residual metallic salt is left there, that is vaporized. Means that is converted. Solid is converted in the form of vapor. That process is called as a fusion. And here, whatever the solid residue is left behind, this solid residue is vaporized. Not only the vaporization takes place, here what happens? On vaporization, the dissociation of the components are going to be taking place. Means whatever the element is present, and that element or a compound is present, whatever in the compound, the different elements are there, those elements are going to be separated from one another. That is, they are converted in the form of individual atoms. There is a individual separation is going to be taking place. You can take an example of, say, sodium sulfate. Here what happens? In the sodium sulfate, when the solution of sodium sulfate is subjected for the flame, the residue is left, and this residue on vaporization, the elements are to be separated. Sulfur goes out in the form of sulfur dioxide, and there is a sodium element, or the atoms of the sodium are left. The third one is the atoms of the sodium. If they are continuously in presence of the flame, the third step is atomic excitation is going to be taking place. You know, atomic excitation means the atoms are previously present in the ground state, and when they are directly comes in contact with the flame, what happens? The excitation takes place, means they are moved towards the higher energy state. If even with the energy of the atoms in the ground state, means before excitation, the atoms are present in the ground state, and in that case, even is the energy of the atoms in the ground state, and when the continuously the flame is applied, then atomic excitation takes place, means they move towards the higher energy state. E2 be the energy of the atoms in the excited state. Then E2 minus E1 is equal to H into mu. This formula is known to you. E2 higher energy state, E1 is the lower energy state, that is the ground state. Excited state minus ground state, that will be H into mu, and mu is equal to C upon lambda, that is known to you, and therefore E2 minus E1 is equal to H into C divided by lambda, or lambda is equal to, what happens here? E2 minus lambda is equal to, here lambda is equal to H into mu divided by E2 minus E1 is the formula. From this equation, we can go for the calculation of the wavelength of the emitted radiation, that is calculated. This is the principle behind the flame photometric technique. I have given the flowchart of the flame photometric technique. Here, the sample, liquid sample containing the elements, means any component or any compound is dissolved in a suitable solvent, you get the solution of that, and that solution of the sample containing elements. This sample is allowed to take in the form of solution, and that solution is allowed to spray, so that the solution liquid is converted in the form of small droplets. When that droplet comes in contact with the flame, what happens? Evaporation of the solvent is results, and there is a formation of residue of the droplets, and that residue of the droplet contains the compound. Then what happens when that compound is continuously comes in contact with the flame? What happens? The decomposition of the residue is going to be taking place, and there is a neutral atoms are formed. The decomposition takes place, and we get the neutral atoms. And when the neutral atoms are continuously with the flame, what happens? There is a formation of excited atoms and the emission of the radiation from the excited atoms. Means here they are in a neutral state, they are in a ground state. When they are directly comes in contact with the flame again, excitation is going to be taking place and the atoms are moved towards the higher energy state. And when they reach to the higher energy state and return back to their original state, they emit the radiations, and those radiations having a specific wavelength, and that wavelength of the intensity of the excited radiations is measured by the flame photometric technique. And this is the principle behind the flame photometric technique, and what is meant by flame photometry I have explained. Next we will go for the instrumentation of the flame photometric technique to the next class. Okay, thank you for your patience hearing.